All right, guys, this problem says how many atoms of mercury are contained in a 9.65 times 10 to the 2 mole sample of mercury. So the three-step problem solving method would involve step one, sorting out what the problem is giving you, and it's giving you 9.65 times 10 to the 2 mole of mercury. The next thing that the problem is, the next part of the problem solving would be to write down what the problem is asking you. And it's asking you for the number of mercury atoms. Now, notice that I didn't write the word atom after the symbol for mercury, because that should be implied. If the symbol contains only one element and only one quantity of those elements, so mercury is one element, and there's only one of them there, there's the subscript one is understood, then the proper vocabulary word to say then after mercury is atom. And so I don't include the word atom because that again should just be understood from basic vocabulary. So again, I'm given the number of mercury atoms as what I'm trying to solve in the problem. So just to summarize, the problem is given me the number of moles of mercury atoms, and it's asking me to calculate the quantity, the number of mercury atoms. So in order to put it together, the simple basic plan in step 3 would be to write down the units in 1 and convert them to the units in step 2. So I'm going to take units of moles of mercury, and I'm going to convert that to the number of mercury atoms. Now, if I can do this in one step, great. If not, then I'm going to have to sort out a sequence of conversions in order to accomplish this goal. But there is a direct relationship between those two, so I can do it in one step. And that's Avogadro's relationship. And Avogadro's relationship states that there are 6.022 times 10 to the 23rd mercury atoms in 1 mole of mercury. So I'm going to use that relationship to establish the correct conversion factor, to establish the correct per expression in order to solve the problem. So putting it all together, now that I've got all my planning done, I can write down 9.65 times 10 to the 2 moles of mercury. I have one conversion factor that I need to use since there's only a one-step direct conversion. And I look at this units and I say, I have moles of mercury in the numerator here. And so they need to be in the denominator there in order to cancel out. I am trying to solve the problem in terms of the number of mercury atoms. So the unit is Hg there, and that means that Hg goes here. And so I can look at the relationship above and say that 6.022 times 10 to the 23rd mercury atoms per 1 mole of mercury, and that gets the correct conversion factor for me. The rest is calculator work. And when I do that calculator work, I get 5.81 times 10 to the 26th mercury atoms. That's my final answer. Okay, thanks, guys.